Do you know the difference between a distance time graph and a velocity time graph? Is the answer no? Then you need to watch this video. Let's go. Hey science fans! So today I'm going to be talking about some physics, paper 2. We're going to be looking at speed, distance time graphs, velocity time graphs, and being able to annotate them correctly. Every paper always has these on. So let's get Okay, so for the P2 paper, you need to know two types of graphs that show the motion of an object. Okay, I'm going to draw them here as a sketch. You need to be able to do both of them. You need to know what the lines mean and what they show. So the first one we're going to look at is a distance time graph, okay? And we always do time on the bottom, and that's usually in seconds or hours or something. I always remember it that T, the first thing you draw is the horizontal line, so that's your time. It's also the same on the other, okay? Now, we're going to do DT graphs. These are distance time graphs, and they are usually used to look at the movement of an object and then help you calculate speed. Now, speed is distance divided by time. Okay, so up the side is distance. And again, I remember that one because, and that's usually in meters, so that is in meters per second. Okay, distance has a vertical line, is the first thing that you draw. Now, a distance time graph will show the motion of an object, and it could show lines that look like this, it could show lines that look like this, it could show a line that looks like this, and it could show a line going downwards, but I'm not going to include that today because it's not entirely relevant to what we're doing right this second. Okay, so if an object is showing a straight line on a distance time graph, we would say that that object is stationary. Because time is continuing, but distance, there's no distance, really. Nothing is happening. The object is still in the same place. Okay, and if we were to, let's say that that distance is 2 and the time taken, well, it hasn't gone anywhere in a given time, so it's irrelevant. Stop talking, Mrs. Corbett. Okay, a line that is moving upwards is moving at a steady speed or a constant speed. Notice here I've got a line with a steeper gradient. This is a faster steady speed. And if I want to calculate the speed, if I wanted to calculate the speed of one of these objects, I would read along the distance until I hit the line, draw down, making sure I use a ruler. Obviously, I'm not right now because lazy. And I would say, okay, so the distance is 4 and the time is, we'll say that's just 2 because that is maths I can do in my head. That's 4 meters in 2 seconds. So it's 4 divided by 2. That means it is going 2 meters per second, and that is the speed. And essentially what you're calculating there is the gradient. So in maths, we do y over x equals the gradient. So the steeper the gradient, the higher this number will be, and the faster the object is moving. Okay? If you are asked to calculate the average speed of an object's journey, so for example, let's say this car then goes back in the opposite direction and goes home, it's still travelling over that distance, you would do the total distance divided by the time it's taken. Now, a velocity time graph is usually to look at acceleration. And acceleration is a change in velocity divided by time. Now, a change in velocity is meters per second divided by seconds. So the unit is meters per second squared, or meters per second per second. Okay, now again, time goes along the bottom, which means that velocity goes up the side in meters per second. Velocity is the same as speed, but it is a vector quantity, so it has a given direction. And again, we could have something that does this, something that does this, or something that does this. Okay, now if an object has a horizontal line in a VT graph, we know that it is travelling at speed at a velocity, let's say that's 2 in this case, and it is taking a length of time to do so. So again, 2, 4, 6, 10. Okay, so there's no change in velocity here, but the velocity is continuing, so this would be a steady speed. Now this line here is changing velocity, it's increasing velocity in the given time. So this one is accelerating. And this one is accelerating faster. Okay, so if I wanted to calculate the acceleration, I would draw the line till it hits, so if I want to say what is the change in acceleration at 8 meters per second or at 4 seconds, I would draw it down and I've got a change in velocity is between 0 and 8 divided by the time taken, 4 seconds, 8 divided by 4 is 2 meters per second squared. Okay, that is how you use them for that purpose. You might be asked, what is the change in velocity between 2 and 4 seconds? So if I look on my graph, between 2 and 4 seconds, it has changed for -2, it has changed speed by 2 meters per second, and how long it took for that to happen, which again is 2 seconds. So the acceleration between those 2 points is 1 meter per second square. That's how you use those. Very simple. This is for all basics from foundation upwards. Okay. You need to make sure that you can draw and label both. So have a little practice. Draw them on a piece of paper and have a little practice. You also need to make sure, if you are doing higher or triple, that you can link both of these in terms of what acceleration would look like on a DT graph, but you also need to be able to think about the forces, because force is mass times acceleration, so you might be able to have to link it to that, or you might have to link it to momentum, mass times velocity, those kind of things. So there'll be a bigger link and more accuracy required. You also might have to work out what the distance is as well from a VT graph. So you would use the area under the graph to work that out. Okay, that was quick. Boom, done.